Greetings, everyone, and welcome to the Linux Certification Virtual Summit. My name is Tiffany Smith, and I will be your host throughout this Linux Certification Virtual Summit. I am a cybersecurity analyst working for a Fortune 500 company, and due to the nature of the work I do, is the reason why you will not see my face, but instead you will hear my voice throughout this summit. I hold the Certified Ethical Hacker certification, the CompTIA Security Plus certification, and the CompTIA Linux Plus certification sponsored by the Linux Professional Institute. The Linux Certification Virtual Summit came about because after I graduated University of Maryland University College, I began to look for Linux certifications. However, there was nothing that assisted me in figuring out the different Linux certifications there was. How do I go about with being certified in Linux? What the Linux exams entailed? Was it multiple choice or was it a practical exam? Which is why I came up with the Linux Certification Virtual Summit. I wanted it to be a one-stop shop for individuals like myself who were looking to become certified in Linux, but was not sure on where to go, how to go, and what they needed to know in order to pass. I have had such tremendous fun putting together this summit for you, and I hope you enjoyed as much as I did. I had the opportunity to have deep dive sessions with best-selling authors of Linux certification books. I've had the pleasure of having these deep dive sessions with people from across the world, people that live in Brazil, Cambodia, Canada, the United Kingdom, the Netherlands, the United States. It's just amazing how worldwide Linux is. And I look forward to you enjoying the summit as much as I did. The best thing about this summit is that it is free. And when I say that it's free, I mean it is free, and you don't have to buy a plane ticket to go to the summit. You don't have to buy a hotel room to attend the summit. You don't have to travel anywhere. You can just load up the videos on your PC, on your Mac, on your iPhone, or your Android, and just enjoy these deep dive sessions. Due to the summit being free, you should consider purchasing a lifetime access to the videos. Once you do purchase the lifetime access to the videos and you become a part of my community, there are bonus videos that you will also receive access to. And before we get started here at the Linux Certification Virtual Summit, I want to thank our guest speakers. I want to thank everyone who assisted me in getting speakers, everyone who has assisted with the website, and who has just been supportive. Are you guys ready? And without further ado, here he is, Jon Maddog Hall, to give our keynote speech here for this Linux Certification Virtual Summit. Thank you.
Hello, my name is Jon Maddog Hall, and I am the board chair of the Linux Professional Institute. First of all, you might want to know a little bit about me. Back in 1973, I graduated from university having a degree of half electrical engineering and half computer software and half business administration. I know that makes 1.5 people, but that's basically how we did things back in those days. I've been working in the computer industry since 1969 on a wide variety of different systems, mostly Unix since 1980 and almost exclusively Linux since 1994. I've worked for a large number of companies and a large range of companies in size, from very large companies to very small ones. I've been a programmer and a systems administrator in a wide range of different jobs, including a university educator, in which case I taught operating system design, compiler design, networking, database design, and many others. I've worked on extremely large systems and extremely small systems. I tend to be a fairly pragmatic person. Not religious about a great deal of things, except I do believe that free software is the way to go in developing new systems. And I've been both a vendor and a customer, so I've been waiting for a bug fix or an enhancement to come from the vendor, and I've been a vendor trying to create that bug fix or enhancement for the customer who needed it. This is you. You're a little geeky, You've been using computers for a long time. You fixed everything on computers for your friends and family, and now you would like to make a living as a computer person. You may have received a university education and you say, I'm set to go for the rest of my life. Or are you? Because believe it or not, things are going to change. You have to think about what the goals of a university education are, and it is not just to get you a job. The goals of a university education are to create a thinking voter, a thinking workforce, and a lifetime of knowledge. It's to help research, to get public research done with public money, or perhaps a combination of public money and private money to create private research, but in any case to advance the concepts of computer science and other sciences. The four functions of any educational body are to set a path of objectives. So if you look back at your university education, you see that there's a curriculum which the university put out that said these are things we're going to teach to make a well-trained, well-rounded person. Then once those objectives are created, they teach to those objectives. For each course that you're going to have, what do you need to know in order to be able to solve that particular problem? After they teach you the information, they want to certify that you actually have learned that information, that you've retained that information, and you can apply it to other things. And this, of course, is done through tests or projects. Then finally, the university or educational body wants to research new objectives so that they can keep up with the things which are needed in present-day industry and civilization. And while we are at it, let's look a little bit closer at the different degrees you have and what they're trying to do with each degree. The bachelor's degree gives you this broad background of math, science, computers, maybe some biology, maybe some marketing. But most importantly, it teaches you how to learn on your own, how to go to the internet or books or other things to get the information you need. The master's degree gives you more detailed and focused training, but it also teaches you how to identify and solve a particular problem. And we typically call this process of identifying and solving that problem the master's thesis or the master project. Your PhD shows that you can actually identify and solve a problem in your own lifetime. A problem that's never been attacked before, a problem that's never been seen before, or tried to have a solution. And you are to define that problem and solve it and prove that it can be done. And we call this the PhD thesis or the PhD proof. This helps to advance knowledge of a particular field. Notice that not a single one of those education goals was about you getting a job. That's kind of a side effect. They're trying to train you how to learn on your own and how to solve problems. And because of that, you become valuable to industry and to civilization. And that's why the government and other bodies create universities, because they know they need that type of training in people. Now, you can have a, quote, university education by following other paths. One path is called cooperative education, where you may go to university for some hours a day, then work at night, or you go and work for 6 months and you go back to university for 6 months. You keep doing this back and forth. And this allows you to apply your knowledge that you get directly to a company, and on the other hand, to see how companies work utilizing that knowledge. Another path for university education is something known as a guild program. This has been going on in places like England and Europe for many hundreds of years. You may have heard of a carpenter's guild or a plumber's guild or an electrician's guild or any of those types, where eventually you become a master craftsman, somebody that knows exactly how to work and what all of the different laws or regulations are. And they take on an apprentice, somebody who's new to the field and wants to learn. And the apprentice works for the master craftsman, and the master craftsman teaches the apprentice how to be a craftsman in that area. At a particular time, the apprentice leaves the master craftsman and goes out, becomes a journeyman, starts their own business, but they continue to learn, and eventually they take a kind of a test to see if they are a master craftsman, and then they too can take on an apprentice. Similar program, but a little bit different, is mentorship, where a mentor takes on somebody who wants to learn and gives them guidance not only in the techniques that they should be using, but also the direction that they should be going with their life. And finally, there's this self-learning path, where somebody can go in and learn on their own by picking up books or magazine articles or learning from the internet, and that is where they go and get their information. Now, when I graduated in 1973, most computers did not have an operating system. You ran one program at a time, you linked the device drivers and the device controlling software into your program. You actually booted your program, not the operating system, you booted your program to run inside the computer. And this was true even for mainframes, because back in those days, a mainframe computer may only have 256,000 bytes of memory. Not 256 million or 256 billion, but 256,000 bytes of memory, and may cost $2.5 million, and these were 1973 dollars. So they needed to run the programs efficiently, and only over time, as the computers logically got larger with larger memory and faster CPUs, did they say, well, we can run multiple programs in them at one time, have multiple people on them. Back in those days, networking was carrying around a box of cards, or maybe a magnetic tape from one machine to the other. But there was no networking like we imagine it today. And security was simply locking the door at night. A very simple thing, because there was no networking. Sometimes you even shut down the computer and booted it up the next day. But of course, all of this keeps changing as we go through time. The hardware has gone from mainframe computers that fill a room to microcomputers that fit on the head of a pin. Software has gone from the single program, no operating system, to things like the cloud, where you don't even see the operating system. It's hidden behind virtual machines. You see solutions which are multi-platform, not just one operating system or one architecture, but thousands or hundreds of different mixtures of architecture and operating system. It could be ARM, it could be Intel, it could be PowerPC, it could be something else as the hardware. You could have Windows as an operating system, Apple as an operating system, Linux or BSD as operating systems, all working together in the same problem. And there will be more of those solutions coming up. Databases. At one time we didn't use databases, we just had flat files, but then along came relational databases and object-oriented databases and NoSQL databases, and maybe even just data structures like linked lists or hash tables, things we didn't need an entire database and the overhead of that. And security, oh my God, it's become horrendous, where every day there's something new to learn about security, whether it be how to make a secure system or how to keep your patches up to date. It's become an entire field in itself. And because of all of this, you have to keep learning. You have to buy books, you have to look at magazines, you have to go to the internet and forums, and you have to attend conferences, and you have to collaborate with other people to help to learn the things you need. So a lot of times people ask me, how do you make money with free software? If the software is free, how do you make money with it? Well, first of all, in the English language, the word free has multiple meanings. It can mean gratis, as in no cost, or it can mean free as in freedom. And we really mean the second one with free software. However, because of the freedom that you have in the software, a lot of times there's a limitation as to how much you can charge for the software itself. And so when people ask me, how do I make money with free software? I ask them, if your name is not Bill Gates or Larry Ellison or somebody like that, how do you make money with their closed source software? Well, the thing is that most people do not buy software, and nor do they buy hardware. They buy the solution to a problem. Maybe their problem they have is they want to play some game, and what they need is a computer and a network connection to do that. But that's not what they're trying to do. They're trying to play a game. And if they could do that with a tin can and a string, they would. You don't go into anybody's house and you see glued to the wall a box of software with a candle on either side like a shrine. You don't see that because the software and the hardware is just a means to the end. And so when you say, how can I make money with open source? You say, well, with closed source, you can make money by defining the problem. What's the problem that the customer has? Designing a solution to solve that problem. Then you can sell them the hardware for the solution, and you can install the software. You can integrate the software better so that one piece of software works with the other one. You can educate the person in how to use the solution, and then eventually you can administer the solution to them as a systems administrator would. And all of these things you can do both with closed source software and with open source software and charge for them. But you can do one more thing with free software that you can't do with closed source software, and that's to change the software to do what you want it to do. And that is something you can charge the customer for to make their solution better. So what do you learn or not learn is the question. And you go into learning about things. Don't just try and learn Cisco networking. Don't tie yourself just to Cisco. It is much better to learn networking standards and implementation in general, and then Cisco networking in specific. Don't just learn about Microsoft Office. Learn about how to use Office products, how to select and use Office products to meet your needs. And you can look at Microsoft Office, and you could look at OpenOffice, you could look at K-Office, you could look at LibreOffice, whatever package you want to pick. But now you know how to select them. Don't just think about Oracle database because it could be too heavy for what you want to do. Think about databases in general and data structures in general. And then pick the one you want, whether it be MySQL or Postgres or Firebird or even Oracle. Don't just learn about Nortel communications when you're learning about telephony. Learn about telephony in general. How does it work? How do you pick out the products to solve the customer's problems? These are the things you should be learning. So what is free culture and how can it help? Well, free cultures kind of started with free and open source software. And after a while, people realized that by using free and open source software, they could reduce the costs of the software solution for the customer. And they could also implement it more quickly because they didn't have to implement the entire solution. For students, it allows real-life projects, which are both fun and useful, to be worked on. And they realize they don't have to do the entire project. They can just do a portion of it and take the other parts from the free software realm. It's learning about free and open standards, which allows interoperability and longevity in software. If you have closed standards, then as the hardware changes, a lot of times the standard has to change too. Creative Commons is an interesting licensing phenomenon that allows you to more easily exchange your text, your pictures, your art, and allow people to use it in certain ways, whether it be with an attribution to say that yes, I took this picture from this person, but they're the person who created it. To say you can have a derivative, which means you can take the picture or the music and change it, add things to it, have a new way of interpreting it. These type of you can also set it up to say yes, you can circulate my picture or my art freely if you don't charge for it, but if you try and charge for it, well then you need to pay me some royalty. And all of these things are covered by the Creative Commons licenses. Free and open source hardware is another example of hardware that is specifically detailed and specified, so it makes it easy for the open source people to support it. But also, it's easy for hardware people to extend the hardware to make it do more. They don't have to start from the very beginning again. And finally, in self-education, free and open culture can make self-education a lot easier. The IEEE ACM has a computer science undergraduate curriculum, which they started many years ago, and every 10 years they upgrade it. In 2013, they made another publishing of this. It is completely available on the net. It gives course numbers for the various courses they feel are necessary for computer science, and a description of it, the objectives of it, suggested texts that you could use to teach yourself that, and the prerequisites for the courses are all specified out. To take a look at how free software could be used to teach these different types of courses, we can look at an example of operating systems design, and we see that in the free software world there's a simple operating system called FreeDOS, which is actually binary compatible with MS-DOS. However, with FreeDOS you can actually see how the DOS operating system works, and students can see how a simple operating system works by looking at the source code for FreeDOS. Linux, of course, is a much more complex operating system, but all of its source code is available for students to study. Likewise, the different BSD operating systems, FreeBSD, NetBSD, and OpenBSD, are all examples of open source operating systems. TinyOS is a small operating system, mostly designed for the Internet of Things, very, very small pieces of hardware. And both CMU, Mach, and Herd are microkernels, so that people can compare a microkernel to a monolithic kernel, such as Linux and BSD. But an operating system is more than just the inner core of the kernel. It also has file systems that it can support. And Linux supports a wide range of different file systems, both all of the FAT file systems that Microsoft supports, NTSC, the Microsoft more complex operating system, Unix file systems of different types, log-based file systems, journaled file systems, more robust file systems, all are supported and have source code in Linux. If you're looking at a network file system that supports NFS and Samba, and these allow you to share files and printers with Apple and with Microsoft, and also with BSD and Linux. If you're looking at networking, almost every networking stack I've ever heard of is supported in Linux, including even ones like DECnet, which are proprietary networking systems that were re-implemented by the free software community. If you're interested in security, there is Security Enhanced Linux and AppArmor. Both are techniques of making an operating system more secure. And if you're looking at distributed type of security, you could look at Kerberos, which allows you to have distributed systems and make them more secure. In graphics, you have the X Windows system, which is a client-server based system. OpenGL is an implementation of 3D windowing or 3D graphics in an open way. If you're interested in clustering systems, either high-performance computing clustering systems, supercomputers, or highly available systems where one system falls down, the other one takes over, Linux has support for all of that. And out of the 500 fastest computers in the world, 486 of them run Linux. About 12 of them run different types of Unix systems or proprietary systems, and 2 of them run Microsoft. If you're looking for virtualization, you have Xen and KVM as virtualization techniques, and emulators Wine to emulate a Windows operating system, and QEMU to emulate different types of hardware upon which you can put an operating system. But FOSS, free and open source software, is not just an operating system. If you want to learn how compilers work, you have almost every language that's used today supported either as a compiled form or as interpreters in Linux. Database engines, as I mentioned before, MySQL, Postgres, Firebird, and others. Office systems like LibreOffice and KOffice and other types of Office products. Multimedia tools for collecting video and music and audio and editing it and publishing it. And voice over IP like Asterisk and various zip types of software for communicating by voice over the internet. If you go out to either SourceForge and GitHub, you find out that there's over 430,000 different projects out there and 3.4 million developers. And this is without China and India and Latin America being fully on board and connected to the internet. What types of programs are we talking about? Programs for capturing and editing audio and video, programs for creating 3D games and 3D movies, Blender in specific, business and enterprise software like OpenERP and other software for running your business and enterprise, communication software, development software, debuggers, linker loaders, bug tracking systems, things like that. Home and education, things like Mr. Home and other home automation, education packages, whole distributions geared towards kindergarten to 12 systems with Linux. Games, science and engineering, there's a whole distribution about science, math, and engineering programs put together. It is called Poseidon. Security and utilities, all different types of utilities for creating secure networks and secure hotspots and things like that. Systems administration for administering multiple architectures and operating systems over the network remotely. Emulators and simulators like Wine and QEMU, which we discussed before, and many others. So open source allows you to try out this new software and concepts basically for free. And the for free is in quotation marks because, of course, nothing is for free. You have to spend your time, you have to spend some disk space, some network connectivity to pull the code down, to install it, and to understand where it goes. But this becomes easier and easier every day. You don't have to use the entire program. You can build on top of other programs. You can take parts of the programs and use it in your code as long as you follow the licensing that came with the program itself. By working on these programs, you can meet other people who have like interests, whether they have interests in photography, an interest in audio, or interest in database design or security. You can meet these people and discuss things with them and share the knowledge between you. And because of all of this, research can go faster because large portions of existing code can be reutilized and allow the researcher to work on just the code that they are doing the research on. So in the new educational model, the things to really learn are things like, how do you do distributed development when perhaps the developers never see each other face to face? How do you license the software? What is the best license that gives both the freedom you need to your customers and to be able to make money in your own model? How do you develop formal standards so that you can then implement and write code to those standards and have it scale and be efficient and everything else that modern day software has to be. How do you motivate software developers that may not ever see each other? They can't formulate the concept of a team because they all work spread around the world. How do you motivate them? And how do you locate and engage the community of users and developers to help you work on your project? How do you innovate everywhere and always? Because this is the way that you make money in the future, is through constant innovation. So today, even the student who has no money can find a college curriculum on the internet, can find the objectives of the curriculum on the internet, can find the information on the internet by going to places like Khan Academy or the MIT, Stanford, or Rice courseware, which is put on the internet. And they can learn from that information and apply that to what they want to do. And what about certification itself? Well, there's three major methods of certification. One of them is to create a portfolio, which is the programs and email exchanges you have on a particular project. And another one is getting letters of recommendation written for you. And the third one is certification, whether it be a vendor and distribution specific certification like Red Hat or OpenSUSE or LPI, any one of those as certification models. So let's take the first one. How do you develop a portfolio? Well, one of the things you can do is find a free software project to work on. Because this is something where you have been working at a job and you decide that you want to expand out into something else. And so at your work, you may not be given the opportunity to work on this new project. So on your own, perhaps at night, perhaps on the weekends, you could find a free software project which is close to what you want to do and start to work on that. And first you might start reading the mailing lists, getting used to the way the programmers code in the project, and you start by looking to see what bugs they have or what minor enhancements they want to do. And you can then take that on, matching the code style of the rest of the people in the project team. Eventually, believe me, the project is going to look at you and say, you're doing a great job with creating these patches and implementing these extensions. How would you like to formally join the project as a developer? And of course, you probably would. Now, as you do that, you keep records of your own contributions to the project. I did this piece, I re-implemented that piece, I made this piece 20% faster, 5% faster. You keep records of that. And then after a while, you can ask for letters of recommendation from the project leaders and your peers in programming. And they'll say, oh, this person really does a great job. They create good software. It's relatively low in bugs. They have good coding style. They work well as a team member. And you can then take this letter of recommendation, your programs, your extensions and everything to somebody who's looking to hire you. And please remember to give praise back where praise is due. Praise is a very low cost thing to give. You shouldn't overgive it because then it becomes hollow. But when you see a good piece of work, or you see somebody doing a good job, a pat on the back goes a long way. And finally, you bring all this work to a prospective employer. When Mark Shuttleworth was thinking about developing Ubuntu and creating a company called Canonical, of course that was based on Debian. So he took the entire Debian mailing list and all of the source code for Debian down to Antarctica on a laptop computer. He spent 9 months down there going through the mailing list, seeing how people interacted, and came back and said, I want you and you and you to come work with me on Ubuntu. He didn't have to call any human relations person or anything like that. He didn't have to pay any fees for hiring somebody. He already knew who he wanted to hire because he had looked at their code and looked at their interaction. Fortunately, if you're a closed source intern or you're working at a company which does closed source, you're not going to be able to do this. You might be able to point to the project that you and 10 other engineers worked on, but you can't show them your code. You can't show them your discussions in the mailing list. You can't show them what you did. And that's a problem. And your contributions are always going to be behind closed doors. Now let's talk a little bit about vendor-specific certifications like Red Hat and SUSE. There's nothing wrong with these certifications per se, but they typically only teach about a specific distribution. And because of that, they can reach a depth of specifics on that distribution, and that's fine. They also often combine certification with training. Like the only way you can get their certification is if you take their training course. You can't learn on their own. It requires expensive travel. It may be more expensive because you have an instructor who's teaching it and grading it. These are all problems. And it's not that vendor-specific certification is bad, but it doesn't necessarily give you the breadth of all you need. Now, the Linux Professional Institute was started, and we are profession-oriented. So we tend to look at what is the necessary needs for a systems administrator, what is the necessary needs for a person working in database, and what do you need if you're working in security, and things like DevOps. What do you need to know to be a good DevOps? We use industry-defined objectives. So we go out to people who are actually doing this work and companies who need these type of people, and we say, what do you need? What are the objectives that these people should be able to do? And then from that, we ask again, if you're looking for somebody that has this knowledge, what questions do you ask of them? What answers should you expect back? And from that, we develop our tests. Our tests are vendor neutral, whether it's IBM, Hewlett-Packard, or any other company, and they're also distribution neutral, whether it's OpenSUSE or Red Hat or Debian or one of the other distributions. We try and be neutral across that. And what this does is give you a broad base of different techniques and things like that, because you typically are going to be working in a mixed vendor shop. We're worldwide. We are in over 180 different countries. There's only about 200 countries in the world, so you can see we're fairly well distributed. And have 125 certification holders today. 125,000 different people have some type of LPI certification. 200,000 certifications have actually been delivered. Each certification requires 2 tests. So there's 200,000 certifications, or 400,000 tests which we've given. And of course, not everybody passes every test all the time. So we have given over 500,000 tests, of which 200,000 or 400,000 of those tests have been passed. And there are some people who are in mid-test, finishing up the second test of 2 tests which they have to take for certification. We do separate certification from training. This allows you to use classroom training, self-guided training, or just training that you get from experience at a job to get your certification. If you look over the objectives of our certifications on the web and you think to yourself, yes, I know how to do all of that, then you can just go and take the test and try to pass it. And if you do pass, then you're certified. If you don't pass, then you should go back and see what things don't you know as well as you thought you knew. We also try to have low-cost exams, but it does cost money to deliver these exams, create these exams, and grade these exams, and give out certificates, and to keep track of the people who have earned the certificates. So yes, there has to be some charge, but we try and keep it as low as possible. LPI is a nonprofit organization based in Canada. So with that, I'm sorry that I'm not here in person. I'm actually in Brazil and Argentina when I was making this recording, and I hope that someday that you can meet me and ask the questions, and perhaps we can find some way of asking the questions here at this virtual symposium. So thank you very much for coming. My name is Jon Maddog Hall, and I'm the board chairman of the Linux Professional Institute, and I'm the president of Linux International. Thank you.